All right, so we learned yesterday or earlier in the week about how to solve two-step equations where there is more than one operation happening to your variable. So far, we've looked at what happens if your variable is being multiplied and added. But there's another type of operation we can look at, and that's division. So, yesterday we talked about that when there is a variable in an equation, instead of using PEMDAS, which is what we would use if there was no variables, if there are variables, we're going to use PEMDAS backwards to undo the operations, which means we do something called SADMEP. According to SADMEP, I'm always going to do addition and subtraction first, multiplication and division second, and then we would get into exponents in parentheses. So really, our operation here, or our process, stays exactly the same because division happens in the same row as multiplication. So what we're going to have to just do differently here is remember that to get rid of division, we multiply. So let's look at an example. Let's say this time we're looking at something like x divided by 2 plus 3 equals 5. Okay, let's go through our steps here. I have nothing to KCC. I can go ahead and add my secret or invisible 1 here. So I've got 1x divided by 2 plus 3. So let's change colors so we can see the work I'm doing. Here's my variable. There's my 1x. The things happening to my variable, right here with the 2, I've got division, and over here with the 3, I've got addition. So I know I've got to get rid of both of them. I know to get rid of division, I multiply, and I know to get rid of addition, I add the opposite. But it's really, really important here that we do things in the correct order. So we use PEMDAS backwards to help us figure out that order. So looking at PEMDAS, as I start to move across PEMDAS, the first thing I get to is addition and subtraction. So I have to take care of that first in my equation. So that means I've got to get rid of the plus 3. So to get rid of plus 3, I add negative 3, and that gives us Dr. 0. Oops, I forgot to divide my equation. Okay, we have to do that to the other side as well, so my equation remains balanced. And now what I'm left with on this side of my equation is 1x divided by 2, and on this side of the equation, I have 2. Okay, so now I really only have one operation left. So I could go back up to PEMDAS backwards and continue to go through, and I see that my next operation to take care of would be multiplication or division. But really, I'm left with a one-step equation with only one thing that needs done, and that's division. So how do I get rid of division? I multiply. So let's change our color again. So dividing by 2, I would cancel out by multiplying by 2. So cancel, cancel, these both become 1s. So now, on this side of my equation, I have a 1x, which is exactly what I wanted. And then I have to do the same thing on this side of my equation. So I have 1x equals 4. One of the most important parts of this process is to do a check step. You guys will see that on your worksheets today. I did not include answers on the back because you have the opportunity here to check your own work. So we're going to take our x value. I'm going to circle it here so we remember that that's our answer. I'm going to take our x value and I'm going to substitute it back up into the equation to make sure that when x is 4, my answer does equal 5. So I've got 1x divided by 2 plus 3. So now that the variable is gone, I'm going to solve this with just normal order of operations. So 1 times 4 is 4, so I just have 4 divided by 2 plus 3. 4 divided by 2 is 2, so then we add 3, and our answer comes out to be 5, which if I scroll back up here, the original answer was also 5. So that means if this side is 5 and this side is 5, my equation is balanced, which means my value for x was accurate. Let's look at another example here. All right, grab my black here. All right, so let's say we've got 4 equals negative 3 plus m divided by negative 4. Okay, so let's go through our process here. I don't have 2 KCC, but I do have a secret 1 here next to the m. So let's go ahead and add that in. Divide our equation down the middle. And now that we've done all the prep steps, now we're actually going to start to solve. So what I notice here is that I have 2 operations happening to m. I have addition right here, so the plus 3 is or the minus 3 is being added, and I have division over here where the negative 4 is being divided. So I need to get rid of both of those. I have the knowledge on how to get both of them, but I need to know which order to do it in. So I'm going to scroll back up here to my SADMEP, and I see that in SADMEP, I have to do addition and subtraction first. It's what I get to first. So I'm going to go back down to my problem. I'm going to find the number that's being added, which is the negative 3. Right here, this is what's being added. So to get rid of negative 3 plus, I'm going to add positive 3. So this cancels out. Add positive 3 to the other side. Over here, I'm left with 7 equals, and then I'm still left with that 1m divided by negative 4. Okay, here is a part I want you guys to listen extremely close to because I'm still seeing a lot of errors made here, even by my students who are doing wonderfully. This is an error that is continuously being made. I get rid of division by multiplication, not by multiplying the opposite. Notice we never say multiply the opposite. We just say multiply. So you're going to multiply by the exact value that it's being divided by. So here I'm going to multiply by negative 4 because that's what it's being divided by, not the opposite. So these cancel, become 1s. Both are positive 1s because a negative times a negative is a positive. And I also have to do that to the other side, the exact same thing to the other side. So now on this side, I'm left with negative 28 equals 1m. So that would be our final answer, but because I haven't provided you guys with answers on the back, you now need to plug this back in to see if we're right. So I know this side of my equation equals 4. Now I need to know, does this side of my equation equal 4? So we're going to plug negative 28 in for m, solve that side of the equation, and if it equals 4, we are accurate. So it was negative 3 plus m, so we're going to plug in negative 28 over 4. Now we're going to solve this with regular PEMDAS because the variable is gone. So in PEMDAS, I do division first, which this equals negative 7 oops, that was a negative 4. Negative 3. So now I've got positive 7 here because I forgot my negative originally. So now I've got negative 3 plus 7 equals 4. So because both sides of my equation now equal 4, I can confidently say that this is my correct answer. Okay? You guys, please rewatch this as you're doing your worksheet if you need it. Keep in mind it's the same process we did with multiplication, only now we have to get rid of division, which means we multiply. Multiply, not multiply by the opposite, just multiply. All right, hope this helps. Good luck on your worksheet.